In section 7.2, we look at the ambiguous case. Let's consider an example. In this example, we are asked to find angle B in triangle ABC if side A is 2, side B is 6, and angle A is 30 degrees. Let's start by drawing a picture. So here's what this triangle might look like. Notice that we have everything labeled appropriately. Angle A is 30 degrees. Side A is 2, and that should be opposite angle A. Here we have angle B, which is the angle we are looking for, and side B is opposite that angle, which side B is 6, and then we have angle C and side C. Now to look for angle B, we have to use the law of sines that involves angle B. So I'm going to write sine of B divided by B is equal to, and we'll use sine of A divided by A because we have information about angle A and side A. Now if I plug everything in that we know, we have sine of the missing angle B divided by side B, which is 6, and this is equal to the sine of angle A, which is 30 degrees, divided by A, which is 2. Then we can multiply both sides by 6. And after we cancel here, we get sine of B is equal to 6 times the sine of 30 divided by 2. Now, to find angle B, we have to use the inverse sine, right? So we're going to basically take the inverse sine of both sides. And by taking the inverse sine of both sides, essentially what happens is the inverse sine and the sine cancel out, giving us angle B. And then we end up with the inverse sine of this expression, 6 sine of 30 divided by 2. Now, you can type this into a calculator separately and then write down the decimal, but I'm just going to type this whole thing into the calculator because the calculator can handle it. So let's go ahead and do that and bring back our result. So here's what I typed into the calculator, and it won't show on this little cutout we have here, but basically what the calculator should display is that you have some kind of an error here when you do this. All right? So when this happens, when you get an error, what it means is that this is impossible. You cannot find an angle B such that this is true. All right. Now, let's go ahead and think about why this is happening. So to understand why, what I'm going to do is I'm actually going to plug 6 sine of 30 divided by 2. I'm going to plug that into the calculator just to see, what is that number. And when you plug that in, you'll see that you get 1.5. And actually, you don't need a calculator because sine of 30, we know, is 1/2, right? So we could have figured that out without a calculator, but most of the time, you would need a calculator to figure that out. So what is the inverse sine of 1.5? Well, we already know this is an error. But why are we getting that error? Well, it's because you cannot have a sine of an angle that gives you a value that is more than 1. So if you try to take the inverse sine of a value that's more than 1, you will always get an error because it's not possible, okay? So what that ultimately means in the context of this problem is that this triangle has basically no solution, right? You cannot solve for an angle B. And what that really means is that there is no such triangle that can exist that has the information given at the beginning of the problem. But why is that? Because when you look at our picture, it looks like we can make a triangle. So why is it that we can't solve this triangle? Well, actually, my picture is not really that accurate. Let me bring in a more accurate picture that will hopefully help us understand why it is we have no solution. All right, so here is a more accurate picture than the one that I drew. So notice that we have angle A is 30, like we have here. Side B is 6, we have that here. But side A is only 2. And if this is 6 units long, 2 is only 1/3 of that distance, so it's a very short side. See, here I drew this much too long. And basically what happens is no matter how you swing this side back and forth, you cannot touch this side over here to make a triangle, right? It's not long enough. So to make a triangle, this side here would have to be longer to be able to touch down to make a triangle. And you can't bring this side down to make it touch because this angle is fixed, right? It's 30 degrees. So you can't change this angle, you can't change the length of this side, and you can't change the length of this side. So when you swing this back and forth, think of it as having a hinge right here, you just can't make it touch down. So there's no such triangle that exists. So when we're talking about the ambiguous case, we're talking about being given information about a possible triangle, but sometimes the information that you're given makes no triangle at all. Other times you'll get a triangle, and even yet you will sometimes get more than one triangle. So this is why it's called the ambiguous case. One final thing that I want to say before going on to do more examples is this situation is what we call the side-side angle situation, SSA. And it's basically called this because what you have been given is two sides and an angle that is not in between the two sides. So if you look at the situation we had a side here, we had a side here, so that's side, side, and then the angle is not in between the two sides. So it's a side-side angle. The side-side angle situation is the ambiguous case, all right? So one possible scenario for the ambiguous case is that you get no solution, right? No such triangle. Let's go ahead and take a look at an example where you do get a solution. So in the second example, it says, find the missing parts of the triangle ABC if side A is 54 centimeters, side B is 62 centimeters, and angle A is 40 degrees. Let's draw a picture. So once again, I want you to notice that we have side-side angle. Now to do this, we're first going to find angle B. And we can do this by saying the sine of B divided by side B is equal to the sine of A divided by side A. And if we plug in what we know, we get sine of B divided by 62 is equal to the sine of 40 degrees divided by 54. Now from there, we can multiply both sides by 62 to get sine of B equals 62 sine of 40 degrees divided by 54. And then we can find B by taking the inverse sine of both sides. And now we just need to take this quantity and plug it into a calculator. So you can see when you plug this into a calculator, you get approximately, right, 47.562 degrees. So we're going to say approximately 48 degrees because we are rounding this to the nearest whole degree. Okay, so we definitely have a solution. But here's the thing. If sine of an angle is equal to this positive number, because sine is positive in the first quadrant and the second quadrant, there is another possible solution for angle B that would exist in the second quadrant. So let me show you what I mean. If we know that sine of angle B is a particular value, and we solve for that angle B and we get 48 degrees, which is what happened here, the other possible solution would be an angle in the second quadrant, which has the same reference angle as the angle in the first quadrant. And that means that our other solution would be this angle here, which is 180 minus 48 degrees, which is 132 degrees. So we have another possible solution, which we're going to call B prime, and B prime is simply the supplement of the solution we just found. So 180 minus 48 is 132. Now, once you find that other possible solution, you have to ask yourself, is this possible? Can angle B actually be 132 degrees? Well, to answer this question, you need to consider the angle that you had in the beginning. The angle in the beginning was 40. Now we're saying B could be either 48 or 132. Now we know it can be 48, but can it be 132? Well, as long as this angle here and the original angle that you started with is not more than 180 degrees together, then yes, you have a second possible solution. So I know this can be a little bit confusing, but basically, in this problem, we're going to have two possible solutions. And so what I'm going to do is I'm going to make two possible solution boxes. And so you'll see in the first solution box, I have the first possibility, which was angle B could be 48 degrees. And my second solution box, my other possibility is angle B could be 132 degrees. To distinguish between these two solutions, I call the second one B prime. Now we have to find angle C. Well, in the first scenario, angle A is 40, angle B is 48, so angle C would be 180 minus 40 minus 48, which would be 92 degrees. And in the second situation, angle A is 40, angle B is 132. Together, these angles make 172, which means that angle C prime would be 8 degrees, right? So again, you find that third angle by simply subtracting the first two from 180. So because we have two possible solutions for angle B, that gives us two possible solutions for angle C, and that is also going to give us two possible solutions for side C. To solve for side C, we'll simply use the law of sines. We'll say that C divided by the sine of C is equal to A divided by the sine of A. So to find side C, we have C divided by the sine of angle C, which is 92 degrees in the first box there. That should be equal to A, which is 54, divided by the sine of angle A, and angle A was 40 degrees. And we could solve for C. C is going to be 54 sine of 92 divided by sine of 40 degrees, and plug that into a calculator. The other possible solution is C prime divided by the sine of angle C prime, which is 8 degrees, is equal to 54 divided by the sine of 40. And this gives us C prime is equal to 54 sine of 8 degrees divided by the sine of 40 degrees. Now let's just plug these both into our calculator to get approximate solutions. You can see from the calculations here that little c for the first one is approximately equal to, again, two significant digits here is going to be 84. So we'll put 84 centimeters in that first box. And little c prime is approximately equal to, again, round to two significant digits here, that's going to be 12. So the other possible solution is 12 centimeters. Now, let me just kind of show you a picture why we're getting two possible solutions, right? So let's bring that in. So here is what is actually happening in that problem. We had our original angle A here. Side A was 54. We had our original side B, which was 62. And then we found that one possible solution for angle B was 48 degrees. But the thing is this side is long enough to touch down here, but short enough where if we swing this side over to here, it can touch down and make a second triangle. So one of our possible triangles is the triangle here, and then the other possible triangle is this triangle right here, and that's the second triangle that we found. And you can see for this one, angle C is much smaller. That's the angle C prime. and side C was also much smaller, and that was side C prime, right? And so that's the sides and angles that we found here. Whereas in the first solution, the larger triangle here, you can see that angle C here is much larger, and side C, which is this side here, is also much larger. And that's the solution that we got over here when we found that C was 92 degrees and side C was 84 centimeters. So these are the two extremes. In the first example, we got no solution, and in this example, we got two solutions. Sometimes there is only one solution. So let's take a look at the last example. So in this example, we have triangle ABC. Angle C is 35.4 degrees. Side A is 205 feet. And side C is 314 feet. So again, we're going to start by finding the angle A here. We can do this by saying sine of angle A divided by 205 is equal to sine of angle C, which is 35.4 degrees, divided by side C, which is 314. Then we can multiply both sides by 205 to get sine of A equals 205 sine of 35.4 degrees, divided by 314. And finally, A will be the inverse sine of this value here. And let's go ahead and plug that into a calculator. And you can see from our calculator here, if we take this to 3 significant digits, this is approximately 22.2 degrees. So that is angle A. Now, we have to say, or A prime could be the supplement of that angle, right? Because again, remember, angle A could be an angle in the second quadrant, and if it was an angle in the second quadrant, it would be 180 minus 22.2 degrees. But if you do the math on this, you get 157.8 degrees. That's your possibility for A prime. Now you have to ask yourself, is that really possible? Well, angle C was 35.4 degrees. Now we're saying angle A prime could be 157.8 degrees. But if you add these together, what do you get? Well, you should see that we get 193.2 degrees. That is not possible because if two angles of a triangle add up to be more than 180, it can't be a triangle, right? So in this case, we do not have a second possibility for angle A. It just doesn't work with the given information. So in a way, that's kind of good news because that means you only have to solve for one solution. So again, now we have angle A is 22.2 degrees. Now we can find angle B. Angle B will be 180 minus the given angle, which is 35.4 degrees, minus angle A that we just found, which is 22.2 degrees. And if you do the math there, you get 122.4 degrees. So that is angle B. And finally, we can find side B by saying side B divided by the sine of angle B is equal to side C divided by the sine of angle C. And if we do the math here, we get B divided by the sine of 122.4 degrees is equal to C, and C is 314 divided by the sine of angle C, which is 35.4 degrees. And if you multiply by sine of 122.4 degrees on both sides, you get B is equal to 314 sine of 122.4 degrees divided by sine of 35.4 degrees. And then we just plug that into a calculator. And we get 457 approximately. 458. There we go. That's better. So our little solution box, we have angle A is approximately 22.2 degrees. Angle B is approximately 122.4 degrees. And side B is approximately 458, in this case, is feet. And there is our single solution to this triangle. So in conclusion, the ambiguous case, when given side-side angle, gives you one of three possibilities: either no solution, two solutions, or one solution.